Hi, in this review, I'm just going to go over a conditional example to try and show you some of the problems that may come up when you're doing them. So what I'm going to do is problem 3.8 in Lang, which is sort three integers. If you didn't know, Lang's solutions for even problems are on the web. And so it's a nice way for you to practice if you really understand beyond what we're doing in the lab and what you do for your homework assignments. I really like them. I sometimes assign problems out of here, so hopefully this was not one of your assigned problems. So I'm going to start a new project. So we will do File, New Project, and using Java 11, no template, and we will call it Sort 3. So in this one, we'll do in this window. Okay. All right. So in here, what we want to do is we're going to ask the user numbers, and we are going to sort them and print them out sorted, right? In non-decreasing order. Okay. So I need a new class, and we will call this Sort 3. Doesn't have to be the same name. Don't forget you're going to need to put your header in. So I'm going to need three, do public static void main. I already have a typo, and we know that because it's in red. Oh, okay. So now what we want to do is we're going to have three integers, and we are going to print them out in decreasing order. So let's have integer, let's see, value 1, value 2, and value 3. And the prompt will be system.out.print, enter an integer. And then we want a space. So if you remember for the prompt, we want to use print, not print line, and then a space. We also want to spell integer right. So it's really nice in IntelliJ, they put that under here. The end of every Java has the sum told me that. And now I'm going to do value 1 equals, oops, I didn't do the scanner object. So now we're going to have to, let's do import java.util.scanner. Now I actually do type .scanner because I often don't remember what libraries they're in. If I do type scanner, I make sure I have the right library util, but you can do .star, whatever works for you. And then here we're going to have scanner, we'll call it input, and remember this to be linked to our keyboard. So we're going to link it to system.in, and remember again, you only need one of these. So value.in is going to be input.next, and we want an integer. So I do that 3 times. Enter another integer. Value 2 equals input.nextInt. Oops, and then enter final integer. And I know this seems like a lot when you're typing, but remember, you really want to give users as much information as you can so they type in the right thing. Value 3 equals input.nextInt. Okay. All right, so now we have to print them out in sorted order. So how do we want to do that? Well, we have 3 numbers. I haven't thought of the algorithm, so if value 1 is greater than value 2, what we're going to do, and I'm going to use curly brackets, then if value, so I'm going to have a bunch of different paths. So for me, value, oops, I forgot the open, have to be in parentheses. If value 1 is greater than value 3, then what do we know that we're going to print out? System.out.print, and I'm just going to print because I'm going to do them all in order. So I'm going to print value 1 and then I'm going to do a comma and a space. Okay. So else, in this case, so value 1 was greater than value 2, and value 3 was greater than value 1. So else, I'm going to print out system.print line, print value 3. And I actually know the whole order here because I know that it's value 3, value 1, value 2. So I'm going to do value 1. Oh, I actually know the whole order in the previous one, so let's go back and fix that. I'll make life easier. Oh, no, we don't. No, we do not. Okay. Plus value 1 plus value 3. 2. Oh. Okay. So the problem with this, I'm going to use curly brackets here, is that in this case, if value 1 is greater than value 2 and value 2 is greater than value 3, we don't know how value 2 and 3 are, so we actually can't print out yet. So we have one more test here. So we now have to say if value 2 is greater than value 3, then we can print out, I don't want to print line, value 2 plus, oh, I don't know what I just did there, plus space plus value 3. Okay. If that's not true, then I know, I'm just going to copy this. We know that value 3 is greater, and we can print that. This is pretty funky, longer than I thought conditional. Okay. So in this case, we know that 1 is greater than 2. In this case, we know that 1 is greater than 3, but we don't know if 2 is greater than 3. And so that's what you're testing here. Here we know that 1 is greater than 2, and we know that 3 is greater than 1 from the way the test is. All right. So we've now handled the case where 1 is bigger than value 2. Now what if it isn't? So what if 2 is bigger? So now if 2 is bigger than value 1, it is exactly the same code as what was on top, except that it's kind of reversed. So in this situation, we know that value 2 is greater than 1. So now you need to test, well, where does value 2, if value 2 is greater than value 3, then we have the same situation we had above here with 2 and 3, except now it's with 1 and 3. That. So otherwise, if that's not true and value 3 is greater than value 2, then we know value 3 is greater than value 2 is greater than value 1, and so we can just print it out. So we're going to print out system.out.print value 3 plus value, let me see, 2 was greater, oops, and then value 1 is last. Okay, so in this situation, we now have to see how do value 1 and 3. So if value 1 is greater than value 3, then we're going to print out value 2, which is the biggest, and then value 1, and then value 3. Okay. Otherwise, I'm going to print out the opposite, switching value 2 and 3. And I want to make sure I get everything of all the combinations we could have. So let me, still doesn't mean it's going to work. Okay, so we're going to have value 2, then 3, oops, then 3, then 1. So we know if we're going to have 3 numbers, just for my own sanity, that means we can have 1, 2, 3, or 1, 3, 2, or 2, 1, 3, or 2, 3, 1, or 3, 1, 2, or 3, 2, 1. So there can be 6 combinations. So let's make sure we have 6 different prints out here. So in here we have 1, so we have 1, 2, 3, 1, 2, 3, so we have that one. Here we have 1, 3, 2, we have this second one, and then here we have 3, 1, 2, so we have this fourth one. Here we have 2, 1, 3, this first one here, 2, 3, 1, this second, and then 3, 2, 1, this last one. So we get all the combinations if I did everything right. You could use print lines here, it's fine. Another thing you may see here that I did is I printed out 1 and then just the rest of the sentence, whereas here I printed the whole thing out. I did that because I don't like writing code twice, mostly, so that's why I did. I did it that way up here, but either's fine for something like this. Okay, so let's build it. Okay, so it built, and then let's run it. So one of the other things, it's going to build it anyway. So enter an integer. So let's make it easy first. Let's do 5, 3, 1. So it did 5, 3, 1. So that one worked easy. So the other thing you want to think about when you're doing things like this and you have all these combinations, you do want to test them all, because you may have had a problem somewhere in the code and it can really end up being a problem. So let's now do 5, 1, 3, 5, 3, 1, and I'm just doing them in different orders. Now let's do 3, 5, 1. Oh, it doesn't matter. Good, that's working. And we still want 1, whoops, 1, 5, 3. Great. And then let's do it in the last space. 3, 1, 5, 5, 2, 1. Okay, so I'm not going to do the last one. It looks like it's working. So what are some you may see in here? And this is kind of, now I use these curly brackets. You don't have to, but I think they lend for readability. I also tend to put new lines for each one of my sets, also for readability. So it kind of stands out. And I did do it here with these if-else. This is called a nested if. You want to try never to have 3 of those when you're coding more, but right now just do what's you have to do for the assignment. There's ways that you can set up your code so that you don't have more than 3, but we're not there. So again, with the conditional statements, it's really important that you select your code, go up to code, and then do reformat code. It's really important because it is going to line up all your conditionals because you can see how it's tabbing in each time. So what can go wrong? A common mistake people make is to put this semicolon here. Now, so for the if, it does the next Java line to the semicolon. So this is a null. Fortunately, we have an error message because it had an else linked with it. But if we didn't, so if I did if age greater than 65, if, let me just do, I don't have an age. Let's do integer age equals 62. Okay. If age greater than 65, system out dot print get a vaccine. Okay. So this shouldn't print it out. So let's test it out. And, all right, because the 62. So let's just do. All right. But now, if you had the semicolon here, what happens? Now, unlike I don't have any red mark here. I do have a yellow. So you are warned. So the yellow is telling you that there's something wrong. So you may want to be paying attention to this, but there's nothing red. It's going to compile. So we compile it and run, and what happens? What did it do? Enter an integer. Oh, I didn't enter all the integers yet. Okay. Okay, get a vaccine printed out. So even though age was 62, because I had this here, so now I only have one warning, and this warning is age is always false because I hard-coded it in. So that's okay. Compile it. That was just for an example. So that's one thing that often goes wrong. The other thing that you can get wrong is this may not evaluate to a true or false. The last thing I wanted to show is string. So let's do string name is equal to Fred, and string name 2 is equal to Fred. Show you the, now the difference here, and you're not going to get an error. So if name 1 equals equal name 2 system.out.println, we have a match. Let's just print out name 1. Okay. So name 1 and name 2 are two different variables, and they have two different reference parameters. Never going to be true. You think it's going to be true. And so for this lab, when you're looking at locations for where people are from discounts, you make sure that instead you use if name1 dot equals. Now you also can do equal ignore case, which will be very useful because you can't ask a user to be case sensitive unless it's a password. And then you put in the second string, and what that will do is actually compare each character in the string. Then you're going to say system.out.println, we have a match. Now, the downside here is that sometimes Java will try and do some optimization. So it might actually store their variables, so it shouldn't do it. But sometimes they will store strings in the same memory location, and that's how it's working underneath, just to be more efficient with space. So unfortunately, sometimes this could work for you. I don't think it will right now. Don't do it. Do this, because It's an optimization feature. If it does do it, you should not depend on it. Equal is checking the reference parameter. And there are times the reference parameter equality matters. When you're in CSE 364, you will be using equal with objects because you will be looking for matching like heads of lists and tails of lists. But right now in CSE and 360, I think 360 would be fair, you shouldn't. You should only be using dot equals with objects. So let's run this and see. Enter an integer. All right, we have a map. Yeah, so it did do it. It did do it for here, which it shouldn't have. So it decided to be efficient because Fred had the same name. So I'm going to fool it a little bit, and now I'm going to do name equals Fred. Let's see if I can fool it now to do what I want. So what happens here? Age is never used. Okay, let's get rid of that. Variable name initializer Barney is redundant. Okay, I don't care. Name.1 equals name.2 is always true. Yeah, we know that. I did it. All right, I don't like it. It should not be doing it at all. That is a problem. So it's doing that for optimization. Still use the dot equals. You should not be depending on optimization, space optimization for that. I just gave it too simple an example. I know how I could do it. I know what I could do. Why don't we do this? Why don't we do this? We'll ask. This should. So let's do okay. And then what I'm going to do is overwrite Barney. Let's see if I can overwrite Barney with see if we can make it do the right thing now. Oh, error. We tried to define it again. I should have paid attention. So what are these yellows now? Barney's redundant. I don't know why. Oh, I guess because we're doing another call. And you get the warning. You should compare using and not equal. So if you're having trouble, look at your warning message. But I do want to show you this breaking. Finally, I got it to break. Okay, so when I'm reading the input and I read in Fred, and I compared it to Fred here, because they are stored in two different locations, it didn't do the optimization. It shouldn't have. That would have shocked me, but I didn't think it would do what it did. So we now have it only working for, we have a really match, even though they are both Fred. So this is wrong. Very wrong. Don't do. And the worst thing is sometimes it works, right? So I think a lot of times when you're writing code, you find code online or you find something like, oh, it worked, it must be right. Not necessarily. The one great thing about Java, though, is that the Java compilers are all written by the same people. So you won't have trouble if you work on a Mac, works, and then you work on a Windows machine, it won't work over there. So that can happen, particularly with the C programming languages and ones that have open source compilers. If you're using a different compiler, something can work on one compiler and not another. So this is what I kind of wanted to show you with working with conditionals and strings. Next week, it may get this complicated. This week, your lab will be complicated. Enjoy and see you in class.